Alrighty, I'm going to run through this problem. An indestructible hamster is thrown horizontally from a height of 3 meters with a speed of 10 meters per second. So, let's say here is our little hamster that isn't destructible, by the way. Alright, it is 3 meters up, and it is being thrown this way with the velocity of 10 meters per second. So the first thing I'm going to do is separate my vertical components from my horizontal components. Okay, and we are going to try and solve for A first, which says how long does it take for the hamster to hit the ground. So let's see what we're already given. The known for vertical is the acceleration due to gravity, which is always 9.8 meters per second per second. We know that the height, okay, on the y component is going to be 3 meters. The initial velocity is 0 in regards to its height before it falls, and we're trying to solve for time. All right, so with that being said, we are looking for the one equation that does not have VF in it. And if you go to the top and you look, you will see that you have change in distance equals 1/2 AT squared plus initial velocity times time. So we start plugging in our numbers, right? We replace our distance with 3, 1/2 times our acceleration due to gravity, which is 9.8 meters per second squared, times our time squared, which is what we're trying to solve for, plus our initial velocity, which is 0, times our t. 0 times whatever number is going to cancel out to 0 anyway, so we can get rid of that. We're going to do 1/2 times 9.8, which is going to give us 4.9. T squared drops, equal sign drops, and 3 still over here. Next step to get t by itself is divide both sides by 4.9. Whatever I do on the right, I got to do on the left. We get t squared equals 3 divided by 4.9, which should give us 0.61. I did the calculations before this to make this video a little quicker. And then the last step, t's not by itself. To get rid of the square, we got to do the square root. Whatever you do on the right, you do on the left. The square root of 0.61 should give us 0.78 seconds. Okay? So I am going to take our time, and that would actually be our answer to part A, 0.78 seconds. Perfect. All right, now part B is asking how far from the thrower does the hamster land. So we know our initial velocity in the horizontal axis is going to be 10 meters per second. We just figured out our time, all right, which is 0.78 seconds, which, goes for both. So our time is 0.78 seconds. And now it's asking us to solve for distance because it says how far. So we're trying to figure out distance. So we use our velocity formula. So this would be for part B, velocity equals distance divided by time. So our velocity is 10, our distance is what we're trying to solve for, and our time is 0.78. So in order to get d by itself, we got to multiply both sides by 0.78. 10 times 0.78 is going to give us a distance of 7.8 meters. Ta-da! So we are done with part B. That is how far the hamster is going to land, 7.8 meters from where it started. Now it's asking us for C, what is the vertical velocity at impact? So it's talking about vertical, so we're going back to the vertical side. All right, so we are trying to solve for, in this case, final velocity is what we want to know. All right, so in this case, we want an equation that has VF in it. Technically, we have time, but I'm going to use the other givens. One that has A, delta Y, and VI. So after looking through those equations, you should pick out VF squared equals VI squared plus 2A times your change in distance on the y-axis. All right, so VF is what we're trying to solve for, equals our VI squared, which our initial velocity, which you can see here is 0, plus 2 times our acceleration due to gravity, which is 9.8, times our distance, which is 3. All right, so VF squared is going to drop, equals 0 squared plus 2 times 9.8 times 3, which if you put that in a calculator, you get 58.8. To get VF by itself, we square both sides because these cancel, and our final velocity should be equal to 7.67 meters per second. All right, so that was for part C that we just solved right here. And you get 7.67 meters per second is the speed of the hamster right before it hits the ground in the vertical component. All right, and then finally, this is kind of the new part. What is the total impact speed? So if we think about our hamster right now, okay, we have, I'm going to redraw this, all right? It's going off on horizontal with a speed of 10 meters per second, and we just calculated its final velocity here is going to be 7.67 meters per second. So to kind of find a combination between the two of these forces, we have to figure out what this side would be using the Pythagorean theorem. So I'm going to call this side A, this side B. Pythagorean theorem, a squared plus b squared equals c squared. So we're going to do 10 squared plus 7.67 squared equals c squared. And that'd be 100. 10 squared is 100 plus 7.67 squared gives us 58.83 equals c squared. We add them all up. We get 158.83 equals c squared, square root, and then this would give us 12.6 meters per second. So this would be the total impact speed. We're taking into account both the horizontal components and the vertical components to get this answer. All right, I hope that helped.